Hello, everyone. Welcome to the PSC meeting. Let's just wait for a couple minutes for other people to join.
Maybe we can sit there.
Hello, David.
Hey, George. So you're ready for everyone to join us, I guess.
David, your voice is muffled.
Okay, how about now?
Yeah,
Any
now,
better?
yes.
Okay, I'll just have to speak louder. Then we're waiting for Aurelian, I guess.
Yeah, let's just wait for another minute and then we can just get started.
Okay.
So, David, it's 10:03, so I think we can get going.
Yeah, so the things that we wanted to discuss last time, actually, we need Aurelian for this. We wanted to get some of his thoughts on how to set up power for the test event, right? Uh, so in his actions, how do you think we should do this?
David, I'm not
Hello?
sure I fully understood what you were asking, your question.
Yeah. So last time, we were looking for input from Aurelians, right? We were discussing about how to set up power for the demo design.
That's
And Aurelian mentioned that he would be able to help us out. But if he's absent today, how do we proceed? What do you think we should do?
I think what we should do is because he can always view the recording offline, right? So I think what we should do is we should describe the work that we are doing
Okay.
and just look at where the help is needed.
Okay. So let me describe then what we have. And let me share. By the way, I'll need to drop off at 10:30. There's Innovation Village meeting that I will need to attend.
Yeah, we can wrap it up by 10:30. Yeah.
Okay. All right. Let me find the right window to good ones I can share about it. Okay, here we go. So, okay, so this is, let me show you at a very high level. Basically, what we have is a design that is on a 50 by 80 footprint. And that design basically includes 4 CPU chiplets and 4 APF4 instances.
David, still maybe it's my side, but your audio isn't really working.
Um,
Maybe we can ask the other folks on the call. Are you able to hear David okay? Okay, there are no complaints, so I guess must be my setup then.
Let me see if this will work any better. How about now? Is it any better?
Yeah, it's much better.
Okay. All right. So we have a design, and our design, the demo design is a 50 by 80 glass substrate. And on it, we have 4 CPU chiplets and 4 HBM4 chiplets connected to them. The CPUs connect to each other through UCAE, and we have one HBM5 on one of the on one side of the CPU chiplet to connect to the HBM4. All right, so we have the signal connectivity, and Signal has already started and completed part of the signal routing for the UCAEs. Next will be to do some SI analysis for that and to do HBM routing and SI analysis for that. But we haven't really talked much about power and how we want to set up the power tree for this design. So the simplest thing I did was, this looks a little bit messy, but let me explain. Basically, the simplest thing we can do is assume that on the board you have 5 volts coming in, and these 5 volts get down converted for each of the supplies on the substrate to the corresponding voltage level. Right? We have one regulator for the UCAEs supply, IO supply, one regulator for the CPU rigid core, and then we have 4 more regulators to down convert for the HBM power supplies. We have 1.8 volt, 1.05 volt, 0.9 volt, and 0.4 volts for the IOs. Okay, so that is the very simple setup that we did. Now, the question is, what we're looking to actually do is get some interesting data, all right, and see if this setup looks fairly plain, fairly vanilla. Would it make it more interesting if we put the regulators onto the package? How many regulators should we put, and what should we think about, right, when putting the regulators? One issue that came up right now with this plain vanilla setup is that the Unity core on the CPUs, on all 4 CPUs, is 200 amps. So one regulator is not enough right now. It's power, right? The regulator that I used, its maximum output is 25 amps. So trying to run it at 200 amps is basically it's out of its operating range, way out of its operating range. Its efficiency drops to negative, and things don't look good, right? So several questions, right, about the power tree setup is, what is better, put the regulators on the board or on the package? What would be a good regulator off the shelf that we can pick, something that we can model, right? Something that we have the data available for it in terms of efficiency of different power and voltage levels, and see what we need to consider in terms of sizing, right? We have some, as I mentioned, we have a little bit of preliminary data for the different designs. For the CPU, right? You can see each CPU is about 90 watts, depending on which supply we're talking about. Yeah, the core is 90 watts. That's the maximum. And Yeah, so we are looking for four CPUs. Then we are looking at about whatever is going to be that. Let me find it. Yeah, we are looking at 370 watts on the power supply. So, what would be a good regulator to use, how to size it, and so on. We have some of the power and current ramps. What should we consider in terms of choosing regulators? How many do we need to add, any redundant, and so on? So those are the questions that I was hoping to go over today and answer some of those. If anybody can, if any of you can help me out with this, that would be awesome.
So, David, a couple of things. So, you do have a power tree that you were showing. Um, do you have the ability to do power plane extraction?
Uh, we have to draw the power plane and then extract it in hyperlinks.
Okay, because there are two main simulations that you would need to do. One is the AC simulation, and the other is the transient. You obviously, with really high currents, also need to do IR. That would more become a issue of current density crowding, right?
Right.
So all of these three workflows are available from major EDA, but is there a academic open source version available that we can use here?
I don't know. I have to take a look.
Yeah.
But again, right? So here's the chicken and egg problem, right? If you're talking about extraction, that means we have some kind of layout to work with. And we're not there yet, right? We are talking about even before getting into that, uh, uh, how do we plan the power tree a little bit better, right? At which point, right? At which point do we consider that putting the regulators onto the package, onto the substrate instead of on the board is a better option, right? We need to do that setup first, so that we know what kind of power is coming into the package, right? And what and how many powers are coming into the package before we can actually start even planning for layout and doing layout and then do extraction,
So
right?
then
So
the first thing would be the zero order design, which is there enough copper available to carry that much current from here to there, right?
yes, okay,
So even if you can somehow do that, would be a major step forward in figuring out, where to put what kind of regulator, because the moment you down convert, current goes up, right?
yes.
So that may be now the big question is, will Oraline be able to help with actual implementation of some of this? That I don't know.
Yeah. Yeah, so when you're using, assuming glass substrate, and Simon, correct me if I'm wrong, but I think all the copper thickness was around 4 microns.
You mean for the RDL?
Yes.
That sounds really thin for for the amount of currents
Yeah,
that we're talking about now.
it is thin. Yeah, so if the current density is an issue, then
No, I'm just saying because you want to do what if analysis at the
yeah,
moment,
yeah, yeah, yeah,
right? So for what if analyses, just optimizing copper thickness and optimizing the stack up might be sufficient,
Yes.
right? Before you go into detailed PI simulations of every interposer or board or package, right?
Right. Right. Yeah, this might come up that it's better to put. I understand that these are high currents, but then the PCB can have much thicker power planes, right? Way thicker than the 4 microns on the package. So it might be better to put the regulator to keep them on the board and try to supply the current through the board and then go up into the package. Is that your I mean that does that make sense?
Yeah, I mean, theoretically it does, but keep in mind that typically you really down convert on the voltage down to the core voltage at very close to the final logic chip, right?
Yeah.
Or the HBM. Otherwise, you have to carry all of that current through intermediate like interposers and packages. So I don't know what's the right answer.
Hmm. Okay.
But I think that would be pretty interesting to see how the future power supply voltages, how will the power trees look like for those? Like right now, it's not even clear what's going to happen with the 60 volt or 48 volt, right?
Yeah.
So if you can bring the down conversion on the package, then the amount of current that you have to carry goes down quite a bit, and power supply is relatively easier.
Yeah. Yeah.
And that's
Yeah.
yeah.
I think I guess I'll reach offline uh, to Aurelian
Okay.
and see what is that zero. How do we do that zero order analysis
Mm-hmm.
to uh, basically understand what our choices are and what to do, how should we approach this?
Okay.
Because I don't know right now.
Okay. So you will talk to Orlin offline then. Okay.
Yeah, I'll have to. Yeah. Is he on the call? Yet?
No, no,
Okay.
yeah.
Yeah, so this is where we are with this.
Oh,
Um, these are the questions that
this whole
came
thing
up.
is pretty impressive. All the progress that you guys have made. Um, so let's see if we can find few more people to join this work.
Yeah,
Okay.
yeah, we do have a little bit of uh, space on the package around the chips to put the regulators, I think, depending on how many we need and which way we decide to go.
Mm-hmm.
So we can take a look at that and see um, it's all around the chips. We do have the space.
Mm-hmm.
So we'll see how that goes. Probably for the HDMs, it might make sense to provision. Obviously, right? We will have to provision regulators for the left side and regulators for the left side and regulators for the right side,
Mm-hmm.
right? Two different ones. But the CPU is going to be interesting,
Mm-hmm.
especially considering that the power supplies for these ECUs in the middle are going to have to come all the way from the outside of the CPUs, right?
Sorry,
Yeah.
there was a fire alarm going on in my background.
Okay. Hopefully nothing is burning.
Okay, David, then maybe we should just stop here because it sounds like you need to follow up with Oralin offline, right?
Yeah. Yeah. Yeah.
Save everything.
Yeah. I'll follow up with him and see when we can talk to him.
Okay. Okay, thanks for the short meeting.
Thank you.
Yeah, thank you.
Thank you.